also concrete, aggregates, and things like that as well. First, a bit of an introduction to our company. You may have heard of us, especially in the area here. We were known as Cadman. So as of January of this year, I guess it's a reintroduction. We are all known as Heidelberg Materials, so we've just rebranded. Nothing else has changed. All our staff has stayed the same. But we are now all Heidelberg Materials. So if you've ever heard of Cadman, Lehigh Hansen, or any of those product lines, that was us. We are all now Heidelberg. For our company, we are a huge global company. We have 50,000 employees globally, about 3,000 different facilities. In North America specifically, we've got 9,000 employees in 450 different locations. So we provide cement to the market, aggregates, concrete, asphalt, and recycled aggregate as well. So we are fairly large here as well. So why are we taking out the CO2 out of cement and concrete? That's always the big question. If we look at any building, this building is actually a great example of it. You've got concrete, you've got rebar, you've got glass, you've got all the materials that make up this building. When you take all of those emissions for that building, concrete makes up 52% of those emissions in this building. About 50 is what I usually say. So everything else, anything else that you use to build this building, emitted about 48% of the CO2, where the concrete and the cement itself did 52%, which is huge. Think of if you build a dam, though, or a bridge or anything like that, that jumps up to like 80%, because now everything out of that is made out of concrete. So the reason why is because it's a huge, we are a huge emitter. We recognize that, but we are going to work on not only managing that, but reducing that as well. Before we continue, today we're going to talk about carbon capture and a little bit about natural carbonation. I do want to mention, everybody always talks about a silver bullet. That doesn't exist. There is no one solution to reduce the CO2 in cement and concrete. It's just not going to happen. Basically, we've already started what we call innovative products, so using blended cements, things like that. Our concrete teams also have low carbon concretes available now. Circular economy, using waste products. So if you're using slag, fly ash, things like that. We also have one of our members here, they recycle aggregate. So you take crushed concrete, take out all of the aggregate out of that, and then carbon capture and natural carbonation. Again, it won't be one solution. It will have to be a combined approach. And now, for what the video spoke about a little bit, we're going to be building a carbon capture utilization and storage facility. The cement making process will stay the same. We'll just capture it at the flue gas level, store the carbon underground. It is the first in North America. It's also the first globally. We are building one in Norway, but that's only 50% capacity. We're going to capture about 1 million tons of CO2 per year, which is close to 95 to 99% of the CO2 from our cement emissions. We do hope to be operational by 2026, late 2026, early 2027. So the big one, lot of info, we'll break this down. We're going to show how we're actually going to get to net zero cement and then net zero concrete as well. First, if we look at the y-axis here, this is kilograms of CO2 per ton of cement. So how much CO2 we're actually emitting when we make cement. The blue bars are all of the emissions. So we start with quarrying. As the video mentioned, we got to take some rocks, crush those down a little bit. So you have some emissions there. You have to transport that. So you'll have a little bit of emissions from moving all of that rock to your cement plant. In Alberta, Canada, that's where I'm at, our electricity grid is a little bit dirty. We have a lot of natural gas, a lot of coal. So we do have a lot of emissions from running our cement plant. And then we have what we call process emissions and combustion emissions. So the process emissions, these are the hard ones. These are very hard to abate. When you break down limestone, you release CO2, and that's just a normal chemical process for when you're trying to make cement. As you can see, they make up about 65% of the emissions in cement, so huge. The other one is the combustion emissions. As the video kind of talked about, is a kiln, really, really hot oven. You need heat to make that happen. To get heat in there, you need to combust something. So those emissions come from either natural gas, coal, depending on what you have available in your area. The green bars are how we're actually going to reduce it. First one is what we call biomass, so alternative fuels. So these combustion emissions, we're going to use natural gas, and we're going to use basically garbage. So household waste, construction demolition, tire fibers, things like that. Biogenic CO2. This one's pretty cool. When you take a tree, it absorbs CO2, grows throughout its life. You cut that tree down, you use it in construction. You demolish that, and we take that construction debris, that tree, we burn it for fuel, And then we're actually going to capture the CO2 that that tree captured with our carbon capture project and store it underground. So essentially removing the CO2 out of the atmosphere as well. The huge bar here is the carbon capture project. So when we build the carbon capture project, we'll be capturing all of the emissions from the cement plant. That's what the big green bar here is. This one's very, very cool. So it's CHP, it means combined heat and power. What we need is, we need a huge gas-powered turbine to make heat for our carbon capture plant. The gas-powered turbine makes heat, but also electricity as well. So with that heat, we use it for the carbon capture plant, and then the electricity essentially removes us off of the Alberta grid, which is coal, natural gas, things like that. What that means is when you make the cement, at our fence line right here, we have net zero cement. So it leaves our fence line as net zero. If you look at the blue bars again, this is a concrete plant, so where we're going to make some concrete. These are the emissions from taking the cement to the concrete plant, emissions from putting some aggregates, rocks, and sand into your concrete, and then taking that concrete to a job site and using it in construction, so those are emissions. Something very cool, if we have engineers in the room, concrete has the ability to, what they call naturally carbonate. It absorbs CO2 from the air. It does do it over its lifetime, so think on a 50 to 100-year time scale. This number is a little bit conservative for us, but it's 20% of these process emissions. Other numbers, the GCCA, the Global Cement and Concrete Association, has that number at about 25%. So it is possible when you have exposed concrete for it to actually absorb CO2 directly from the air. So if you take all of this together and natural carbonation, you basically end up with net zero concrete as well. So when we think back to that graph of 52% of the emissions in the building were from concrete, we're going to basically bring that down to zero. We have had this third-party verified as well, so it is transparent. And again, carbon capture will be the cool part. However, it's not the only solution. So thank you for taking the time, and I hope you actually learned something about it.